Hello everyone, this is Sri. In this video, we'll be discussing about load flow analysis in Digsilent PowerFactory environment. So I have segmented this video into three different sessions. First, we'll be talking about the load flow. I'll try to give a brief introduction about the load flow analysis, and second, we'll try to explore the functions in Digsilent PowerFactory environment. Third, we'll do a case study and we'll analyze all the results of it, and we'll try to extrapolate them on the graph. So load flow. So load flow studies are the most common of all the power system studies. We might have come across different studies, short circuit analysis studies, grid connection studies, harmonic studies, but this is the fundamental. Load flow study is the fundamental study. So if an electrical engineer want to validate a power system based on its control and operation, he might come across these questions. Are the voltages of every bus bar in the power system acceptable? What is the loading of the equipments in the power system? Transformer, transmission line, generators, they have their own loading limits. Are they within the limits? What is the best operating condition of a power system? Does the power system have any weakness? If so, where are they located and how can I countermeasure them? All these questions can be easily answered by performing load flow analysis. So the reason for performing load flow analysis can be categorized into three mainly. So network planning and operations, generation scheduling and optimization, and when it comes to short circuit or stability analysis, first thing we need is an initial condition. These initial conditions are taken from load flow analysis. Let's take this into account, these two aspects: present operation and the future operation of a power system. Before modeling any power system, we have to take these two aspects into account. So let me put these two questions. From these questions, we'll try to understand what it is. What happens if the existing generator in a power system trips for any reason? Might be fault or might be load shedding, whatever it is. What will happen? Are the power system is running within the limit? Is there no problem in the power system? Is there no blackouts in the power system? The second question is, what happens if there is a future expansion? How does the system behaves when a new generator is connected to the system? We'll be answering these two questions at the end of this video. We'll perform analysis in Digsilent. Let's see how it goes. Now let's move on to the load flow. Load flow is used to analyze the system in a steady state condition. That means it is a condition where all the variables and parameters are assumed to be constant. That's very important. For example, let's take this diagram. It shows a load profile, 24 hours load profile of a particular power system or a particular area. So if you want to analyze this system, if you want to find the behavior of this system, for example, let's take a 10 a.m. We will initialize a 10 a.m. into the system and we'll perform the load flow analysis. So as I told you before, it's a steady state analysis. So it will reflect the system condition for a certain point in a time. That's very important. So in a nutshell, we can say it's like taking a picture of a power system at a given point in time. So while performing load flow calculation, these four factors can be determined. One is four parameters can be determined: the active and reactive power on all the branches, voltage magnitude, and phase angle of all the nodes. The other factors that needs to be considered, and this Digsilent provide us the sophistication to do, is the application of this load flow can be divided into normal and abnormal system conditions. In normal system condition, we know how much the generator is going to dispatch and the load demand. So it's very, very easy for the system, for the software to perform load flow analysis. When it comes to the abnormal system condition, where it's very hard to assume all the parameters are constant, we can't do that. These conditions prevail when there is fault, or when there is a load shedding, or when there is a generator goes out of a system, when there is generator slips out of its condition. All this condition prevails in abnormal system condition. Digsilent PowerFactory help us to perform those functions by giving an add-on option in their environment. So there are 4 factors, as we told before, the 4 parameters that are involved. So each bus can be classified into 4 categories, 3 categories mainly, but I'll talk about the 4th category later. So generator bus will be knowing the active power, and voltage will be specified for that bus. When it comes to the load bus, the active power and the reactive power, the consumption of active and reactive power is known. When it comes to the slack bus, the voltage and the voltage angle, bus angle, is known. There's one more thing to mention with the slack bus. Slack bus carries out balancing power in the system. It provides power when there is a shortage. So there is the 4th one called device node. It is used to represent specific devices. For example, SVS, which helps in voltage control of a particular bus. These buses are represented as device nodes. So in the further sessions, we'll be moving on to Digsilent environment. We'll try to understand these concepts in more detail.